Okay, folks, so we've been talking a little bit about polygons lately. We've been talking about what a polygon is. We've been talking about how to classify a polygon as far as based on the number of sides, whether it's a triangle or a quadrilateral or things like that. And we talked a little bit about the interior angles in a polygon and how many degrees they add up to. So our next kind of topic that we're going to be on for a little while is finding the area of different polygons. Okay, now area means the amount of space inside an object. How much space is inside of an object, right? So you might want to find like the area of your floor. If you're putting down hardwood flooring, you might want to know the area of your floor so that you can know how much you're going to need to purchase, or something like that. The area of your walls, so you have an idea of how much paint you need to cover your walls. Anything like that would be an example of area where you're talking about the amount of space inside a two-dimensional object. Okay? Now we measure area in square units. So when we're talking about area, we're talking about actually 1 by 1 little squares. And how many of those will fit inside your object? All right, so it could be a 1 by 1 centimeter, 1 by 1 inch, 1 by 1 foot. It depends how big the object is, what unit you want to use. But what we're talking about when we're talking about area is how many little square units will fit inside of the object. Okay, so that's how we're finding area. Now, notice up here I have drawn some quadrilaterals. Today, for the next couple of days, we're going to focus on finding area inside of quadrilaterals. So I have parallelograms up here. Now this is a parallelogram, looks like your traditional parallelogram that you're probably used to. It has two pairs of parallel sides. These sides are parallel and these sides are parallel. So that's your typical parallelogram. Now down below here you probably recognize this as being more of a rectangle. But guess what? That's also a type of parallelogram, because these sides are parallel and those sides are parallel because of all the right angles. So even though we know that is to be a rectangle, it's still a type of parallelogram. And then down here is also our friend that you probably recognize, a square. All the sides are the same. It has 4 right angles, so that's a square. But guess what? It's really technically a type of parallelogram because the opposite sides are parallel. So all of these are types of parallelograms. Okay. Also a rhombus, which I didn't draw up here, which has all 4 sides the same, is another type of parallelogram. So these are all types of parallelograms. Now the good news is if you want to find the area of a parallelogram, any type of parallelogram, it's the same formula, one formula. All right, so that's all you need to know. So if you want to know how much area there is inside this parallelogram, or how much area there is inside this rectangle or this square, you only need one formula for all of them, right? And that formula is that the area is equal to the base times the height. That is your formula. Base times height, period. A lot of you probably know some form of that formula, because when you're growing up, you know, middle school or whatever, they always say area equals length times width, which is a true statement for rectangles and squares, that area is equal to length times width. But I like to use a more general formula for any type of parallelogram, whether it has right angles or not. The area is equal to the base times the height. Okay? That's it. Now, so for example, let's put a few measurements in these figures. If I'm dealing with a parallelogram, this is where it's a little different than a rectangle or a square. Because in a parallelogram, let's say I knew that this side was, 9 inches. And this side is 5 inches. Well, you can call this the base, but that's not the height, because it's not the straight up and down height of the figure. So when we're talking about base times height, we need to know how tall is that figure, straight up and down. So when you're dealing with a parallelogram that doesn't have right angles, like a rectangle or a square, here I would need to know this length right here. So let's say I find out that that length is 4 inches. So to find the area of this, I could call this the base, and then this is the height. I'm actually not going to use the 5 of the slanted side to find the area. I'm not going to use that. Because if I'm calling this the base, the bottom side the base, then the height is how high the parallelogram is. So this 5 is really irrelevant to me. It's base times height. Base times the height of it. Okay? So for this, that'd be base is 9 inches times 4 inches. And the answer, that'd be 36. Now again, we're labeling this, since it's inches times inches, we're labeling it inches with a little 2 on it. That stands for square inches, like I said at the beginning of the video. There's 36 little square inches that would fit inside that parallelogram. So when you're finding area, you're doing base times height. And if it's a slanted figure like a parallelogram, it's the base times the straight up and down height in the middle, measured from top to bottom, straight up and down in the middle of the object. So you may not use the other side as part of your calculation. They might put it in to try to throw you off, but you actually don't end up using that number. Now with a rectangle, with rectangles and squares, it's a little simpler, because since the sides form a right angle, then the height is the other side here. So if I knew that this was 12 inches, and I knew that this was 4 inches, that if this is the base, this is the height, because it is forming a straight up and down right angle. Over here, this side wasn't the height because it was slanted. We needed to know the straight up and down height. But here, this is the height. So for finding the area of this, all I would have to do would be the base, which is 12 inches, times the height, which is 4 inches. Multiply them together, okay? And I get 48. And I'm going to label it inches squared with the inches with a little 2. 48 square inches would fit inside of that rectangle. Okay? And then down here for the square, obviously now since it's a square, all the sides are the same. So if this right here is, let's call it 8 inches, then you know they're all 8 inches. 8, 8, and 8, right? So to find the area, I just have to do base times height. So one of the sides I call the base, and then again, since this forms a right angle, this is the height right here. So base times height. I just use 2 of the sides, the base and the height. And again, since this forms a right angle, this side is the height. So the area would equal 8 inches times 8 inches, which would be 64 inches squared. So there'd be 64 square inches that would fit inside of that square. Okay? So finding the area of a parallelogram is actually pretty simple. You need to multiply the base times the height. Whether it's a parallelogram, whether it's a rectangle, whether it's a square, those are all types of parallelograms. So for all of those figures, you can use base times height. Just be careful when it's a parallelogram that doesn't have right angles like this. When it's a slanted parallelogram, your more traditional parallelogram, the base and the height, you've got to make sure you find those correctly. The height will not be the slanted side here. The height will be straight up and down. How tall is the figure? Okay? So area, the amount of space inside the object. For a parallelogram, area is equal to base times height. You just need the base and the height. You multiply them together. And then you get your answer of how many square units will fit inside. In this case, I was working with inches. So when you write your answer, you always write the label with a little square unit. That's it. Okay? So you're going to do some practice with this today, in the next couple days. And, we'll be working with area for quite a while now. We'll start looking at other figures eventually. For now, we're just looking at quadrilaterals, particularly parallelograms, but eventually we'll get into triangles and some other types of figures. Okay? Hope everybody's having a good day.